Okay, this is the Algebra 2, Section 3.2 video lesson for solving systems algebraically. So in the last section we were solving by graphing. Now we're going to solve algebraically, which has two methods that you've learned previously, which are substitution and elimination. So we're going to start with substitution. So that's where when we have a system, we can solve for one of the variables. If it's easy to solve for one of the variables, what you can see is if you have one that doesn't have a coefficient, coefficient is a number in front of the variable. So here we have a 3, a 2, a 4. This y doesn't have one, it's an invisible 1. So we can easily get that y alone by subtracting 2x from both sides. And then if we do that, we get y equals negative 2x plus 10. And now we have an expression for y here, and we could just plug it into the other equation for the y, right, since they're equal. And so we can just plug this right in there, substitute this in for that y, and rewrite this as 3x plus 4 times negative 2x plus 10, and that equals 12. And so now we have just one variable here, and we can solve for that. So we'll simplify this left side. This is 3x, and then we have to distribute this 4, so negative 8x plus 40 equals 12. Then we can combine these two to be negative 5x plus 40 equals 12, and then subtract 40. And then I won't make you walk through all these steps each time. Hold on. Okay, and then we divide both sides by negative 5. We get positive 5.6. Okay, and then we're going to plug this x back. Once we have an answer for x, or a value for x, we're going to plug it into the one we solved for y in. So then negative 2 times 5.6 plus 10. This equals, if you just use a calculator, negative 1.2. So that is my y, right, because this is solved for y. So this, right, we're going to put the answer as a point, right? Remember we're solving graphing, that would be a point, and our answer is x comma y, it's going to be a point. In this case, it's going to be 5.6 comma negative 1.2. Okay, and then I won't do this right now just because it will take too much time, but if you can just plug in these here, and you can check them, see that they work. Okay? So here's one for you to try on your own. Press pause and then solve using substitution, and then check back for your solution. Okay, and then hopefully you got negative 2.5 and positive 2.5. So this is my x and this is my y. Because if you solve, right, you can see this one had a coefficient of 1, so there was no coefficient there. And then if you just solve for the x, so you can just plug that in right in there for that x, and then get your solution. Okay, so that was substitution. Now we'll do some solving by elimination. So elimination is the method where if you want to get the coefficients matching and opposite so that you can just actually add the two equations and then one of the variables will cancel. So in this case, we're looking for matching coefficients on matching variables. So here you want to have it lined up so it's x, y, and then constant on the other side of the equal sign. And then look for matching coefficients. So this is 4 and a negative 4, so this is perfect, that's what you want. So this is telling us this is already set up for elimination. And so you can actually add these equations. And so, right, each equation. So basically you're going to add these two together, add these two together, then add these two together. It's going to be a new equation. So this is going to cancel. We're eliminating a variable. And that's why we want that set up. So this was set up nicely. This goes away. That becomes 0x, which we don't have to write. Then when you add these two, it becomes 5y. And when you add these two, you get 25. And now we have a new equation, 5y equals 25. You just divide both sides by 5, and y equals 5. Then once we have y equals 5, we can choose 5. We can choose either of these equations to plug y into, 5 for y. I'll just take the top one, 4x plus 2 times 5 equals 9. 4x plus 10 equals 9. Subtract 10 from both sides, 4x equals negative 1. So x equals negative 0.25. And so that's our solution, negative 0.25 comma 5. And then just with the calculator, just plug these in. Like I'll just do 4 times negative, right, this would become negative 1, and then this would become 10. So 10 minus 1 is 9, so that worked. And then this one, it would be 1, right, this is negative 1/4 times negative 4, this becomes positive 1. 5 times 3 is 15, 15 plus 1 is 16, so you can check that it works that way. Okay? Okay, so this one, it says for you to solve on your own, but I don't think we're quite there yet. And that's because the example before it was already set up for elimination. This example isn't set up for elimination, so I want to go over that with you guys first. So you can see for my x's, this is a -2 and this is a 5, so they're not the same and they're not opposite. This is an 8 and this is a -1, so they're not same. They are opposite though. And and if you can just find a number to multiply this by to make it a situation where you can eliminate, right? Since this is a 1, if this was an 8, it would be opposite, right? So let's multiply this by 8. And in order to do that, we have to multiply the whole equation by 8. So this guy gets an 8, this guy gets an 8, and this guy gets an 8. So let's rewrite this equation. This becomes 40x minus 8y equals, what is this, 160? Okay, so now let's just look at these two equations and let's add them. Okay, so here we have 38x. Here they eliminate, so that was the point of that, and then equals, and then we can do these two. 160 minus 8 is 152. So there's our equation. 38x equals, and I should have written that 38 a little bit closer. So let's divide both sides by 38, and then x equals 4. Okay, now we can plug this x equals 4 into either of these. I just choose the top one because why not? -2 times 4 plus 8y equals -8, and we can solve for y. So -8 plus 8y. 8y equals 0, right? If we added 8 to both sides. And so 0 divided by 8 is still 0. So y equals 0. So this answer would be 4, 0. And we can plug, and we can check that, right? Since y is 0, these go away. So does -2 times 4 equal -8? Yes. Does 5 times 4 equal 20? Yes, it does. So that works, and that's our solution. Okay. Okay, so I'm not going to have you do this one on your own either because this is a little different as well. And so, again, if we're looking for solving it with elimination, right, these two don't match, these two don't match. And there isn't an easy one to just multiply by that they would match. So we're actually going to have to multiply both equations by a number. And I would say maybe we would stick with, since these numbers are lower, so you want to find the greatest common multiple between these two. And that's just going to be 6, right? And if you multiply this by a 2 and this by a 3. So let's multiply this equation by, and let's make one of them negative, one of them positive, because right now they're both positive, right? So let's make this one times -2, which means all 3 of these guys get that. And let's multiply this one by a positive 3, so that they are opposite signs, so we can easily add them. You can subtract them, it's just when you're subtracting, it gets more confusing. It's just easier to add. Okay, so let's make this top equation 6x plus 21y equals 12. And then let's make this red equation -6x minus 10y equals 10. Okay, and now let's add these together. This eliminates. This becomes 11y, and this becomes 22. And then we can just divide both sides by 11. And y is 2. Wasn't that nice? And then just pick this top equation for fun. You could do the second equation. It's fine, either one. And that equals 4. So this is 2x plus 14 equals 4. 2x equals -10. So x equals -5. And we don't want to circle it until we've checked. So this becomes a -10 plus 14. That equals 4. That works. And then this becomes a -15 plus 10, which equals -5. And that works too. So then since we've checked it, let's circle it. And that is our answer. Okay, finally, one for you to try on your own. I think you've had enough instruction on this. Press pause and solve this system of equations using elimination, and then check back for your solution. Okay, so I'm going to record this anyway. I got the wrong answer, and I got the wrong answer because, I know it's the wrong answer because I decided to do the check. So I wanted to go through this with you guys because maybe this happened to you, you didn't get an answer, and I actually already circled it before I checked. That's not okay. Okay, I've erased it. Okay, so let's find my mistake. So I thought these both had to be a 15. So 15, 35. It's 15 times 5. I did it in my head. No, 75, I got that. Then I thought this needed to be a -3, -15x, -6, +12. That's right. These eliminate. What's 35 minus 6? 29, I got that right. 75 plus 12. I got that right, 87, and then 87 divided by 29 was 3. Okay, so y is 3, and then I plugged it into this equation up here. So then 3x plus 7 times 3 equals 15, 21. Oh, 15 minus 21. Look, there's my mistake. So look at just one little negative sign can throw you off on these things. That's why this is annoying. So really take the time. And here is my -6. This becomes a -2. So this should be -2. And so when I plug in the top, this becomes negative 6 plus 21. Oh, look, and what I did too. I said that 6 plus 21 was equal to 15. This is how fast I'm doing it. No. There we go. That works. And then negative 10 plus 6 equals negative 4. There you go. So it's really important to check, especially if you're like me and is trying to zip through this stuff. Make sure you're checking. Okay, and now that I've found my mistake, I can circle my answer. Okay? So hopefully you got negative 2, 3, and you're annoyed with me having to walk you through my mistakes. But we all make mistakes, and we learn from mistakes more often than we learn from right answers. So I hope that was helpful. Okay, and then the last page, this is just when we have like inconsistent systems. So, right, look here, we have a nice matching. We have our negative and our positive, so we can just add these two equations and look what happens. This goes away. Then this one also eliminates. This becomes 0, and then this also eliminates. They're basically the same equations. When they subtract them, they subtract. So we ended up with a true statement. 0 equals 0. This is true. So this is infinitely many solutions here. Basically, any number that you plug in should work for these. Or actually, not any number. Any number on this line, because they're the same line. So there's an infinite amount of solutions here. Not any number, but... Okay, and then for this one, we can see we have it matching here, so we can add these two. This eliminates. This also eliminates, right, because they're opposite. So this is 0, but then when you add these two, you get 16. 0 does not equal 16. This statement is false, so that means there is no solution. These are going to be our parallel lines, and these are going to be our same line. Okay, and that is it. Time for practice. Enjoy.